In question 3, we need to show this. So if we can find the area of this segment in 2 different ways and then put them equal to each other, hopefully we can rearrange it to get what it says here. So one way to find this segment is to do segment area equals the sector area minus the area of the triangle. And since this is all in radians, the sector area is a half r squared theta minus a half AB. It's a half AB sine C usually, but we use theta. Now in this question, this is R and this is R2, and the angle is X, so it's a half R squared X minus a half. A and B are both R, so that'll be R squared, and then that will be sine X. That gives a segment area of a half R squared, which we can take out to leave this. So the segment area equals that, but we're also told in the question that the shaded segment is also 5% of the whole area of the circle. So that means that the segment area also equals 5% of pi r squared, so it's 0.05 pi r squared. And if we know that the segment area equals this, it also equals this, we can put those two equal to each other to get a half r squared x minus sine x equals 0.05 pi r squared, and the r squareds are going to cancel, and you could probably multiply everything by 2. So if we multiply everything by 2, we've got x minus sine x equals 0.1 pi, and then if we get everything to equal 0, we've got x minus sine x minus 0.1 pi, which is 1/10 of pi, equals 0. So that's part A done. In B, we're using the Newton-Raphson method, which says if fx equals 0, then the iteration is xn plus 1 equals xn minus f xn over f dashed xn. So if we let, in this question, this already equals 0, so if we just let fx equal x minus sine x minus 1/10 pi f dashed x, let's just put this out of the way. If we differentiate this, we're going to get 1 minus cos x. So that gives us our formula of xn plus 1 equals xn minus the original function, which is xn minus sine xn minus 1/10 of pi, all of that over the derivative, which would be 1 minus cos xn. So that is the Newton-Raphson formula we could use. In part C, we then have to actually carry out the iteration with a starting value of 1.2. If we put 1.2, we need to put 1.2 in wherever we see an xn, so we put 1.2 instead of all of these values. So I'll write out the first iteration. That'd be 1.2 minus 1.2 minus sine 1.2 minus 1/10 of pi over 1 minus cos 1.2. And if you type that all into your calculator, you should get 1.27245 something. Leave that exact on your calculator. Use the answer button on your calculator to do these iterations. You don't need to write all of this out again for the next iteration. You can just keep pressing equals on your calculator to get the next one, which is 1.26895. It's important you write down what you get after each iteration. 1.26894, and so you can see that already we've got this root pretty accurate, so we can be pretty sure that what the root is to 3 decimal places. So the root is 1.269 to 3 decimal places, which is accurate enough in this case. If you did it more accurately, that would be fine, and you would get full marks for that. But I think 3 decimal places is enough.